Okay, welcome back. We're continuing our conversation about polynomials, simplifying them. So this is actually on Z6. So I'm going to go ahead and get rid of this. This is, like I said, it's kind of a continuation, but this one's really a bit more specific to Z6, which is multiplying a polynomial times a binomial. So let's go ahead and get started on that. So in order to multiply polynomials, first, you multiply all the constants and coefficients. As you remember from, or might remember if you watched the other video, your constants are numbers just by themselves, but the coefficients are the numbers right in front of a variable or right in front of a letter. So you're going to kind of pull all of those out and multiply them together, and you'll see that in the examples. And after you multiply all your constants and coefficients together, then you multiply all of your variables. But when I say you multiply these variables, they have to have the same base. They do not have to have the same power, but they do have to have the same base when you're multiplying. Remember, when you add and subtract, they have to have the same base, same power. But when you're multiplying, they only have to have the same base. So let's look at an example. I've got 5x times 4x times 3. Now, the way you need to read this in order to understand how you do this, you have to read that as 5 times x times 4 times 3, or times x times 3. Why is that important? Because since you're seeing that every last one of these is being multiplied by all the others, that means you can put them in any order that you want because of the commutative property multiplication. And that's going to make this where we can do this. I told you first you're going to pull out all your coefficients, all your constant. So I've got 5 times 4 times 3. Okay, then I'm going to pull out all of my variables as long as they have the same base, and they don't have to have the same power. So I've got times x to the first times x to the first. If you want to put a 1 there, you can. You don't have to, but you'll see why that might be helpful later. All right, now I just multiply these. 5 times 4 is 20. 20 times 3 is 60. And then I'm going to multiply these. Well, how do you multiply variables? Or how do you multiply exponents, I mean? Well, you put the base down. What base is there? It's x. Then you add the powers. That's 1 plus 1 is 2. So 60x squared is the simplification of all of this. And we're going to use that whenever we multiply a monomial times a polynomial. So let's look at that. Well, first, before we do that, let me go ahead and give you an example. Let's let you work this one. Go ahead and hit pause. Okay, are you back? Okay, great. First, we're going to pull out all of our constants and coefficients. Well, there's a 4. That's a coefficient, right? And there's a 2. All right, pull it out. All right. Now I'm going to start pulling out variables, but they have to have the same base, same power. No, they only have to have the same base. I'm sorry. They only have to have the same base. Both of these have the same base. So that's times y to the 5th times y to the 1st. Again, if you don't see the 1, you know it's a 1. If you want to write it down, that's fine. And then finally, I just have times x. Okay, so now I can start simplifying this. 4 times 2 is 8. Y to the 5th times y to the 1st, add the powers. So that's times y to the 6th, because 5 plus 1 is 6. And then I just have the x hanging out over there by itself. Okay, so that's how you would do that. All right, now we need to understand how to do this in order to do what we're going to do next, which is we're going to take a monomial times a polynomial. That's a 1 term times 2 or more terms, times as many terms. And what do we need in order to do that? We have to use distributive property in order to do that. We have to use distributive property. All right, so what does distributive property looks like? Well, what that is we distribute the multiplication. So first thing I'm going to do is I'm going to take a times b. A times b, that's a positive a times a positive b. And then I'm going to take positive a times positive c, which is a positive a times c. That's how you do distributive property. Now, we're going to show ourselves that this works. So we're going to do a proof. This is not a mathematical proof. It's not a mathematical proof. You have to quote the laws and the theorems and all that other stuff. We're not doing that. We're just going to show ourselves how this works. So on the left side, we're going to write 3 times the quantity 4 plus 5. And we're going to go ahead and use GEMDAS. So 4 plus 5 is 9. So we've got 3 times 9. So we know that that equals 27. All right. And in the next video, I'm going to show you how to do this with the distributive property.